So once again, this takes us back to my lectures online that are available that we have, so you're welcome to access them. So what I'm going to do is step back a little bit about data science, right? So what's the purpose of data science? All right. So everything we talked about is basically extracting information and knowledge from data, right? That's what we're trying to do here as engineers, is extract information and knowledge from data. But what you may not know, what I think you do, you suspect it because I've been talking about it so much, is that there are actually 3 pillars to data science. Okay? Here you are, computer science and engineering. Then you have the mathematician. When you apply math to the domain, you get stats. When you apply computer science to the domain, you get data processing. When you apply computer science and math, you get machine learning. And the domain expertise is always forgotten. That's what we've been talking about so far. Is that problem that the physician, the nurse, any healthcare professional who is the domain expert, he plays an equal role in data science. You can deny it all you want. It won't make it true. Okay? And keep that in mind that that's what you need in order to get data science. A fair representation of all 3. So basically stats, you kind of say math stats. You're not going to have a mathematician at the table, generally, because that's too theory. It's applied math, right? So it's going to be stats, computer science, engineering, and your expert. And the 3 of you are going to make up the data science team. So these are the core values of the data scientist. Very messy, I apologize, but just to give look at the colors, right? Essentially, this is business in kind of yellow. Green is machine learning and big data. Light blue is math. Dark blue is programming. Red is those are the domains. At the top here, you have the different types of people: data business persons, data creative, right? So kind of storyteller, data developer, and data researcher. So look at the way it's distributed, right? And who has what. So if you're in business, obviously your biggest component is business. So you got to have a little bit of a mixture of math and machine learning and statistics and very little programming. Makes sense. You're a business person. A data creative looks very balanced with a minimum, the least ingredient in that. The data developer is going to have a big chunk of programming, and less of statistics, lots of machine learning, and less of business. And the data researcher is going to have a lot of statistics. You need to understand exactly what we're talking about to understand the data. Very little programming, math, of course, and machine learning very little. So this shows you ability. Well, the most kind of balance is going to be a data creative. The data creative is someone who is a storyteller, someone who truly understands what's going on at all levels. Okay? So I would tend to say here, that's kind of more what I do. You guys as engineers are going to tend to live here. Right? Lots of machine learning, lots of programming. But you have to keep in mind, nobody's perfect. There isn't the perfect person. Okay? It's a part of the team. They're always a team. Okay, so what's this? I already told you about the story of big data. Remember, it was volume, velocity, and variety. So lots of data coming into one, different types of data. There's another 2 here I wanted to bring out. One is veracity and value. So veracity is not a common word. But the reason they chose to be so veracity basically means authenticity. Correct. The right data. So this is so you want to make sure you have the right data. And then the last one is value. And once again, there you go, there's value. That has an impact on the data. Does your data have value? Very important to remember when you're dealing with your data, okay? If it doesn't have value, then who cares about it? Okay, so let me give you a little example. So this was my first startup. It's called ACE, ACE, the processing age. And our product was called Carry. And it was a medication delivery device. And the medication delivery device was based on this problem of medication adherence. So who here, if you're willing to cure, was prescribed antibiotics to reduce medication the whole point? Anybody here? Okay, the rest of your other. So medication adherence is a problem. It's not easy. Antibiotics is a problem. It's going to be medication for depression. Because the side effects are horrible. Right? I don't know if anyone wants to, but if any of you have been on medication for depression, the side effects are unpleasant. And so you'll be not really feeling better on medication, you get all these side effects, and you'll stop treatment. So medication adherence, I got the more important don't plug in. So the problem is, if you don't take your medication that's prescribed, it can be problematic for the patient. Makes sense? So that's the problem here, is if you don't take your medication properly, you can end up in an emergency room, well, within reason in India, you may not know, or you have in your seniors, you end up in a nursing home. So once again, I was talking to, just this morning, we were talking about the differences in India, right? And one of them is family. So the perception that, your family stays together in India is much stronger than it is. So meaning that, grandfather is home, kids don't leave home for a very long time, we take care of it. It's wonderful. I mean, great, by the way. But, whereas in North America, your seniors tend to go to nursing homes for the final week. And if you don't take your medication, that increases the risk that you're going to go to that nursing home early. Okay? So that was the reason for this medication device. Okay? And what it did was it delivered, you see here all it was a device that we literally put a cell phone here, right, in front of the device, and in the back is where you put your medication. For those of you that are in pharmacy, your medication is delivered in cell phone pouches in a long stroke. So those of you that are mom and dad, grandma, grandpa, that are on medication, instead of having all these bottles, you have them in pouches for each session. And so you roll that out and you put it in the back of this device. You put it in the back of the device, and what this does is the phone, you can enter the phone. It will set that down. When the patient will set the alarm, it will remind people the circle of care. So it will remind you, the adult son, right? Grandpa didn't take their medication. And so you call home and Grandpa, come on, man, take medication, right? So it's just a way of encouraging people to take their medication. So that's what the purpose was. And this is, obviously what you can plug into is activity monitors, and vital monitors, the whole thing is, it's still full of stuff there. So the reason I was involved, I was the chief science officer for the company, one of the co-founders and the chief science, the early founders, where there was three of them. And my interest, of course, is data. And so by collecting all this data and sharing it and processing it, I could use it for it. And so that's what we're talking about today. So here's, we're going through the V's. So volume, in this case, we assume 5 million pair units deployed in Canada, and each are scheduled for 3 medications a day. There's, when they're delivered, the name, all that information about the medication, the additional integration devices, let's say the plugins or weight scale, the chronometer, and those types of all. So here's the volume, here's the tons of data. This is for 5 million people. 5 million people. That's my neighborhood. Right? So in Canada, 5 million people would be a large proportion of the country. Oh, sorry. So the next one is velocity. Inevitably, you have these 5 million people. So let's just say for 500 million. That'd be about right. So let's say 500 million people on this device. The amount of data coming in is a lot of data. It's a lot of data, right? 500 million people using this, and every time the expression is deployed, you get those. That's a lot of data coming in. So for you guys as engineers, you need to think of that. How do we manage all of this? The variety, of course, we have different types of data. So we have logs, schedules, we have numeric data from measurements, we have textual data from touching it, in the morning. How are you feeling today? And then image data, potentially, we have medical video recognition of the medication, right? So that was a problem for us as a company, was that if you had people, that you're supposed to be helping people, what if the people do not? So this device is not going to force you. So video recognition is one of them where we have a phone, right? So there's cameras. So you can just record. So they have to record taking the medication from you. So now you have video, right? Sorry. Veracity is you definitely need it to. So the example of the video is you want to make sure it's accurate, right? Stuff like that, right? If somebody else looks like you think right? That would be bad, right? So that's not good. And then why do it is the value. So what's the value of the data? Because storage of that data, back in the day, I was like, what? That's a lot of data. But this thing, 500 million. That's going to be a lot of data that you have to store, and that costs money. So for your company, that costs money. So there has to be value in the data you use. So now let me tie it into a clinical value. For what we do here, we're training models. So about 30%, a third of the population of seniors are going to fall every year. Now that's a problem that exists in time certain. And the problem with that is they get hospitalized for in India, and you get hip fractures, which unfortunately can lead to never leaving the hospital. Okay, very, very serious. And it costs a lot of money in Canada to manage this problem, solve it. And so for us, like in this at the time, probably a little more than so it's about $2 million. So it's a lot of money, right? It's a lot of money, right? It's all in thinking about so what do we do? These are risk factors, obviously. So the risk factors are falling. So we need to assess why are they falling. So you have acute illness, obviously you have a fever, you have delirium, you have fall over. Balancing weight deficit, somebody brought up gait, for assessing weight. So that, you can just have gait issues. Chronic conditions and disabilities, of course, cognitive impairment, low vision, obviously not wearing glasses, you want to watch it, you fall over. Muscle weakness and reduced physical fitness, right? If you're not active like you're supposed to, you're type 2 diabetes, and you're not taking medication, right? But, so behavioral risk factors. So those are like physiological. Now we have behavioral. I'm going to go through them all. But, inevitably, what we do, my mother is so bad at it. So she deviates, right? And so when she dresses, she needs to look at this one. And she has these problems, right? She has these problems. But she's only wearing little sandals because it looks nice. And you can imagine if you have, not stable and wearing sandals, you're going to okay, compared to shoes that are, like skinny to the knee. And so their behavior, come on, mom, wear your shoes when you go for a walk instead of these little flimsy sandals. And, that's good. So when you look at the evidence, what you have to do when you do your project, right, is you have to see why, what you're looking at is the problem and how you're going to provide a solution. Right? Once again here, complications related to diabetes, such as neuropathy, retinopathy, these are all the contributing results. Right? So there, I'm just tying it into anti-diabetes. This is where all of this can tie in. Right? That's the evidence. There's theory with diabetes. So the question is, what do we do to prevent falls? So this is where we're now going to do this device. How can, using our device, not my device anymore, I'm just opening up. How can using that device prevent falls? And that's your question, and what you need to do using this potentially big data problem. Right? So, this is what AI can use. So obviously, virtual assistant, this is just everything that we've done, we've talked a lot about this, self-driving cars, it's everywhere. Healthcare and medical engineering, right? So AI in medicine, that's of course. This is more of what we were talking about in terms of, seeing which moves we're going to use. This is computer-aided diagnosis, my results. I'll talk about it as well. But what we want, I'm going to get to the okay, so you know what? I might have set up the slide I wanted to do. Sorry, let me okay, I cut up the two slides. I'm just gonna voice it. Sorry, let me get back to the end of the area. Sorry. Okay, yeah, no. Okay, so how can we prevent falls? So tell me, with this medication delivery device, how are we going to prevent falls? How could we prevent falls? So the problem is, in our case, the device is taking the medication properly. If you don't take the medication properly, you could have complications that lead to right? So that's the premise. So how are we going to use AI in order to avoid that? Well, how do we use that? We have mental life, we have data reflection, we have software. How are we going to actually prevent falls? Well, Valerie, sure, but what model are you using? What is the model? Before we get started, what are the models? What are the models? I think that's what I'm doing. Diagnosis? Well, based on diagnosis. Okay, so what you can do is suppress your model. So now we're looking at different diagnoses. It's not everybody has heart failure. You could be on medication for diabetes, you could be on medication for heart, you could be on medication for liver, mental illness, right? Then you have a mixture of those medications that's called college. So what are we modeling? Diagnosis of fault. Okay, so diagnosis of fault. We're saying classification. So falling yes, no. So how do you see that? This is what I like about this, right? How do you see that? So we're diagnosing falling yes, no. But how do you see that? How do you express that to your user on the device? Okay, what's the message going to say? You fell? So what's it going to alarm? What's it going to alarm? You are calling? Yeah. But what do you guys do? Right. What do you actually tell you? What do you follow? What do you tell us? Oh, risk for the future. So risk. Correct. So risk. You're going to provide a risk, a value, an appreciation of risk. And that risk can change day to day. Correct. Because you have input variables, like your weight, like your device knows it's circulation, right? If your radiation is exactly what you said, you're on a certain, you have a certain diagnosis. You can model the risk of farm. And so you can do whatever you want. You can be creative on your software development. You can be very creative in terms of how you display that risk. It could be a number, could be risk per day, risk per week, risk lifetime risk, whatever you want, right? Risk in the next 10 minutes. You can do it by color. You change the color of the screen. Right? Kind of yellow. Uh-oh. Right? Red. Oh my gosh. Whatever. Is everybody know what it is? Who do you call? Who do you call here? You want to what's that? Okay. So it's a little bit different. Okay. So I just know not to call my own. So that's when you're modeling your risk based on the input parameters. So that's just a good example of how you would coordinate a model prediction method with medical rights. That's correct. That's an excellent question. And that is the black box thing. Okay? So absolutely, you have a very complex problem. And you model it using the neural network. You're not going to know which of those variables contribute the most to the distribution of the algorithm. To say, whoa, you're good. So how do we know that? Okay, the great question. Oh, that's a great answer. You're absolutely right. Explainability. So what's explainability? So how do I do that? Do I ask the model? Hey, it's a black box. I'm not going to tell you. So how do you do that? Can you work with the other? Yeah. Video analysis. Yeah, actually there was a company in the UK working with the radar company. So we were radar projecting that. The reason they were using radar is because video is not the device. But they're using radar. So you're absolutely right. So you could tie in that absolutely to recognition. But so let's answer the question, how do we get explainability? How do we know? How do we share? How could we share? With the user saying, hey, you're going to fall, and we think it's because you're on medication or you have something to do, something happens, right? So how do you do it? You engineer. Tough one. So it's a very difficult area, by the way. So explainability and observability is relevant. New area is very difficult. So the most useful way of doing it is parallel processing. Okay? So you have a machine learning, deep learning, fantastic algorithm And what you try and do is you model in parallel, another like an explainable model. And by doing so, and obviously you match the evidence, right? You're going to get major local models. And then you can explain the neural network model by saying, what the model is doing is use a weak parameter because it's parallel with local. Is it correct? No. But is it helpful? Yeah. For this solution, it's very different. That's what we do. In medical imaging, we're a little blunt here because I showed it previously. That's fantastic. But showing you the areas of interest that the model uses to make decisions. That's all. So that's awesome. Because the user can say, "Ooh, I agree with that. That's what I would have thought too." And so then they do. But for numeric data modeling, very challenging. So generally, it's in parallel with what you do. There's also other techniques like shaft, and there's a whole bunch of things. But it's not easy. It's very hard. And so it's waiting. So as a business person, I would say, or I would do like you would work with the medical team, and you would say, based on your experience, what people follow with these types of conditions, what would you advise you give them to get their results? And you would just that's what I would probably do. For this person, because I wouldn't want to go because I don't want to, So if I take that risk, great. But do I want to make the same thing like I'm going to do? That's not a good idea. And so you probably would do a standardized approach, right? So if there's a risk of falling, you would tell them, please check the following. Did you take your medication? Are you feeling any different today? Did you or whatever, something like that. Please contact, whoever. That's what you would do with the software. So that's a fantastic question. That's such a common problem. Any questions on what we done about what we start with? Oh, we did one. That's all I sure. Okay, so any questions on that? So that's just an application, let's say, an example of an application to a medical thing. Okay? The rest of the talk today is what this entire week is about, right? And so, I thought I'd go into questions for you. We're going to cover that too. Cardamom, we're talking about, these are other, all these applications we're going to talk about. I'll talk a little bit about butterfly, prostate, we're going to talk about prostate. Actually, I think that's So why don't we go to questions? Who has questions for today? We go back to any questions for what we talked about? Sure, general. Oh, general. I get excited because I did dentistry too. I was like, oh, right, all right. You guys are in the dentistry. Okay, general. Because you guys So I'm going to go to the money back. That's the they kind of take the bank and they get the test and everything stuff. You let the lead, you can pick up and then you the second result. So you'll leave the bank. I not only have I come across that, I use it. So that's a great area for us. And that is basically it comes down
because when you're any kind of device that has, CPU capability and CPU capability, it's basically a mobile device. Right? My mobile device, whatever you want to call it, is that. It's not connected to here. And so, what's the problem? The problem is you're absolutely right. Storage power. So when you guys train a model, you need a lot of research, right? You need a ton of research. Graphical processing. And the reason for that is much better with mathematics. So you need a ton of it to train on. So you need a ton of it to do that. Who here has actually used a model? Anybody? Has anybody deployed a model? Right, so that area is something that I would recommend you teach and use, even if it's small data. The reason for it is you're going to realize that you're going to be so excited you've got some amazing models that is 99% accuracy. When you actually deploy it, you might be grossly disappointed. Because either the model just won't work in any way, shape, or form on infrastructure or computer, or it just doesn't work out in the real world. It just doesn't get it. So, to answer your question, what you need to do is make your model smarter. When you do inference, it's called inference. It means that you're actually using the model to predict the weight of the next person in the room. You don't need necessarily a CPU. And the reason for that is you now have all the weight of the model that's been decided. You're done with training. You're done. It's not iterative anymore. It's not like, woo, we're working for 4 hours. No, it's done. So when you do inference, what you want is milliseconds. Hold on. For that answer to come back. So your model can be very large. If you were to use Redmond or some massive model, you have thousands of parameters. It's just not going to go. It won't fit physically. So what you need to do is use architectures that are made for data. They exist. So if you're doing PyTorch, or if you're doing TensorFlow, or if you're doing Google, they have architectures for this. Okay? And so those architectures are critical. So it's probably versus super architecture. In doing that, generally you do what's called distillation. So you distill your model, you're cleaning your model, and you take stuff away and then you just forward. So that is a very interesting area of research. And academically, interestingly, it's not, I don't know, it's not a huge area of interest, because academically, most people don't control the model. But in business, it's huge. Because everybody wants to put it on mobile. The other goal is now, I can't remember that. Some people say, oh, I'm still behind people. But most new phones are able to find a way. They have to be good design. And in doing so, they can accommodate larger models. So the combination of that, doing right programming, and then having the phone. Will permit the use of a lot, but there doesn't have to be false to be a medical. So we're talking about it's extremely rare that you don't have some connections to the good, but you need it to be updated. And you need it to be something to check on things here we go. So what we're also doing now, and I'm doing this in Costa Rica, is you have a light mobile version. Right? So you're out in the field, and you're using butterfly ultrasound, which is a portable ultrasound that is plugged right into your phone. You have a second booster, and away you go. So when you're out in the field and you have no connection, it still works because I'm using potential for learning, what's called hyper-mobile, we're going to use the model. It works. So my model is very basic. You can only guess no. And then, as soon as I get back to my clinic from visiting my patient, it connects automatically to the internet, and it runs the data again on another model, which is a full model, which now gives me chiropractic, which is the thyroid, the RAD, it gives you a score, essentially, of the risk of it being cancer. And then it gives you that score. But I can't run that model off of so just the basic yes, no, I do what I feel, but when I reconnect, I can You're going to say maybe, there's not like usually I talk to medical so they say, oh, wait a minute, what are we going to get from a yes, no? Right? Reason yes, no. Well, what's nice about it is it's not only easy, the thyroid is multiple. It does give the user who's not necessarily an expert an idea of, I can scan. That's usually the big one, right? So if you do a scan and you don't what does it feel deeper? And then your software goes, hey, then they go, oh, wait a minute, I guess I got this. Right? So that's what it does. It gives you a little guidance of the field. You also report it. And so then the proof afterwards you use it. Okay? So yes, you're right, it's not going to be first salary, but it will be for someone who's not fully trained. Because you got to imagine, I'm sure there's many remote communities where there are no visual cell phones. Who goes out and is going to be the expert? Is the world expert on thyroid? No way, right? So who do you send? You send like Bob, and no clue to go out there and get pictures, right? So that's where the software is very useful. Because if the user, the professional, is not trained to figure out the other healthcare provider, they can still do an okay job because it's telling them, look here, look there, that was bad, this is whatever, and then, okay, I better get all this, and then you go back and do your stuff. Make sense? So that's the advantage of I'm just using Octagon, but of course, there are other portable devices. Also, there's probably no obvious. Right? I mean, people are kind of saying portable, they use that. So you're not a clinician, and you're not going to have a test going on there. I mean, you see that confident? Oh, there's a pretty easy to come off. Like, is it really that useful? I mean, it's cost. You don't need that. But it also kind of you can use for wow, what an application. Right? And so it is cost. Okay, any other questions? Look at that. That was good? You're at lunch?